Hello everyone and welcome back to the channel. Today we're going to be talking about agents because agents are coming and you should understand how they work. You should know how to build one. Today we're going to talk about what are the components of agents within Amazon Bedrock specifically, how you can easily build one, and we'll talk about this little tool that I've built to assist you along this process. Remember, if you like these types of videos, make sure to like, share, and subscribe to help let me know that I should be continuing to do this in the future. Now, let's get started with it. Why am I saying that the agents are coming? Well, because last year, 2024, was the year of RAG, the year of retrieval augmented generation. Virtually any customer working in the Gen AI space has used last year to explore incorporation of RAG into their workloads, and many have been successful at doing so. Now, the next step beyond that, which is going to be the focus of this year, are agents, AI agents, and this is where the companies are going to be spending their time and effort this year, 2025, to implement agents as AI agents continue to mature throughout this year. Now, the great news is that Bedrock makes it very easy to build and deploy agents. And since Bedrock is a serverless service, you don't have to worry about managing them, don't have to worry about patching them, don't have to worry about scaling them. Bedrock does all that for us. Now, before we get started, let's talk a little bit first about how does Bedrock run agents? What does that actually mean from the context of Bedrock? And to explore this, we're going to take a look at this documentation page, which I'll share in the references in the description of the video. And this is where you'll find some information around how Bedrock agents work from the perspective of how do we set them up during the build time, as well as how do they work during the runtime when we're actually interacting with them. Now, let's take a look at the build time first. So when we're building agents, there are a few components that we have to include. You have to include a foundation model. This is a large language model that the agent is going to be using to rationalize, to think through how to solve the problem, what are all the required inputs, to understand what tools are available and what the appropriate inputs and outputs of those tools are. So it becomes really important to select a performant and fast large language model to serve as the foundation model. For instance, some of the proprietary models, like what Anthropic has released with the Claude, Sonnet, and Haiku models, could be a great fit. If you want to go the open source route, you could select the DeepSeek R1 as a great option. If you're interested in DeepSeek R1, make sure to check out this video that I've created some time ago, just about a day or two after DeepSeek has released their model. Now, at that time, the only ways to run DeepSeek R1 on AWS included the custom model import into Bedrock or deploying it to SageMaker. Now, earlier this week, there was a release around the DeepSeek R1 now being natively available in Bedrock as a fully managed LLM. So this becomes even easier. But if you're looking to better understand what the model is, how it works, make sure to check out that video above. Now, once you select your foundation model, the next step will be to specify instructions. So these are the instructions for the agent to explain what do you want that agent to be doing, what types of tasks do you want it to be performing. And then in order to actually take some actions, we'll have to specify either action groups or a knowledge base. Now, the action groups allow your agent to call different tools or implement it in, say, Lambda functions. Now, this Lambda function can have implementation of any logic in a variety of programming languages like Python, Java, Node.js, Go, Ruby, and so on. Action group allows you to specify different actions that are then implemented using Lambda functions that agent can call. Alternatively, or in combination with action groups, we can also specify knowledge bases. And knowledge bases allow us to incorporate RAG, right, what the last year was all about, to incorporate RAG into the agent workflow. This allows agent to have access to some of the recent or internal information that the organization may have in order to be better informed around how to solve particular problems. And finally, we can also specify the prompt templates. There are 4 base prompt templates. They're already built in, already available as part of the Bedrock agents. And these the prompt templates are used for pre-processing, orchestration, knowledge-based response generation, and post-processing. Now, the good news here is that you don't actually have to touch these. You can leave them as is, leave the default best practice ones, but if you'd like to delve into customizing these, you are able to do that as well. So at that point in time, we have a set of action groups. You can have multiple action groups or just one with multiple actions. And we can also have the knowledge base set up, which the agent can interact with using the LLM that we've selected in order to rationalize which of these it should interact with in what way possible. Alongside that, we'll have the prompt store available within Bedrock as well, where various prompts we want to use and reuse can be stored there as well. So at this point in time, in order to build action groups, we're going to need a schema that describes how different actions can be taken by the agent, as well as the implementation of those agents, implementation of those actions via Lambda functions as tools that the agent can call. So once we have that in place, then during runtime, these 4 steps are going to be completing the pre-processing step where the data is being prepared for the agent. This is going to be, again, helping the agent to contextualize and categorize the input provided by the user. Then, of course, the biggest piece is going to be that orchestration piece that can involve calling different actions and interacting with the knowledge group. And then that is followed by post-processing. So with that, we now have ability to have the agent built out and agent that is ready, prepared for us to interact with it. As we interact with the agent, we're going to be able to view and monitor these traces that get emitted by Bedrock, which allows you to get into the head, if you will, of the agent and see how it's thinking about problems, how it's approaching different problems, and what action it's deciding to take. So with that, I think we have a pretty good understanding around how agents work, how they're implemented in Bedrock, and just how easy it is to run them in Bedrock. Of course, to really understand how easy it is, it really helps to actually go ahead and do it. So we're going to be doing that here next. Now, when it comes to building out agents, we just mentioned you have to specify instructions, you have to specify Open API schema, you have to build those Lambda functions. So if only there was a tool that makes this really, really easy for us. And of course, there is. I built one in PartyRock. I called it Bedrock Agent Generator, and this tool is going to help us build the necessary artifacts for our agents, including the Open API schema, the Lambda function code, and the setup instructions, as well as the instructions for the agent itself. Now, we're going to keep this really simple in order to keep this demo quick, but all that we have to supply is the agent description. So we're going to say this agent should be able to perform various arithmetic operations by utilizing tools that are available to it. So let's just leave it at that. That should be sufficient here for just a quick example. And I'm going to run this PartyRock app so you can start generating the instructions for the agent. So these are the instructions that we can assign to the agent when we create it. So the instructions include accept numerical inputs and request arithmetic operations from the user, identify the appropriate mathematical operations to perform, use available calculation tools to perform the requested operation, verify that inputs are valid numbers and operations are mathematically possible, return the calculated result with appropriate precision, and handle errors gracefully. For instance, division by 0, invalid inputs, and so on. And we want to support both integer and decimal calculations. Excellent. Now, as we were reading this, the Open API schema has been generated, and we can see the different paths have been included here. The addition path, if we scroll further down, there's going to be the subtract path. Scroll further yet, there's going to be the multiply path, and so on and so forth. So this is going to be the schema that tells the agent, hey, what are the different tools that it can use, and these tools are then going to be implemented within the Lambda function that we create. So with that, we're going to scroll past this, and we're going to take a look at the next generated block, which is the Lambda function implementation that we can just go ahead and use. We can see that there's a variety of helper functions that have been specified here, like how to handle addition, subtraction, and so on and so forth. If you scroll further down, we're going to find the Lambda handler, which is kind of like a main function for Lambda. This is the function that gets called when you invoke, or when anyone invokes a Lambda function. And we're going to see that there's a variety of paths that are specified within the OpenAPI schema that are listed here, like add, subtract, multiply, and so on and so forth. And we scroll further down, there's going to be the set of action responses specified, as well as some exception handling for that graceful error handling that we had in the description of the instructions for the agent. Now, this is followed by some discussion by PartyRock around what was created, as well as the setup instructions. So the setup instructions are going to walk you through what steps you can take to actually now take these artifacts and go and create the agent. If you have any questions, there's also clarification chat here that allows you to interact with PartyRock and ask it any questions that there may be if you have any questions around these artifacts or what to do. Now, I already kind of know what to do, so why don't we get started with that. I'm going to go into my AWS account, and I'm going to navigate to Bedrock service. So let's take these artifacts and let's go ahead and create our Lambda function. So I'm going to navigate to the agents, and I'm going to say create agent, so we can go ahead and create a new one, and I'm going to call it math agent. Now, let's go ahead and create this math agent so we can proceed with configuring it after it's been created. So with that, I'm going to try and maximize our working area here. I'm going to skip the description. This is mostly metadata that is just helpful for us humans, not necessarily required here. I'm going to say create and use a new service role. And for the model, we have Claude 3.5 Sonnet pre-selected, and I'm going to stick to that. So let's scroll further down. This is what has been selected, so let's go ahead and keep that as is. Now, instructions for the agent, these are the instructions that we are going to be having agents have when someone is interacting with it. So to get that, let's go to PartyRock app and let's get those instructions that have been generated. So instructions for the agent, let's just copy that and go to instructions here. We're going to paste, just quickly review that everything was copied as expected. That looks good. Let's now scroll further down. Let's go ahead and create an action group, which is going to allow us to incorporate the Lambda as a tool here. So I'm going to say add, and I'm going to, again, just maximize our working area. And here I'm going to say action group. This action group, let's call it the math operations tool. And I'm going to just give it a quick description saying this tool allows the agent to perform various arithmetic operations. Now, with that, we're going to proceed with defining what the actions are with the API schema. So let's select define with API schemas, and we're going to say quick create a new Lambda function. Now, this is really nice because when Bedrock creates the Lambda function for us, it's going to also set it up with the appropriate invocation permissions, allowing Bedrock service to invoke that Lambda function. So we don't have to do that ourselves. So let's keep that recommended option, scroll further down, and then we can say, let's define via inline schema editor. So we can just paste the schema that we have. Now, I'm going to remove this schema that's available here, and I'm going to go back into PartyRock, and let's copy our schema that we have here. So we're going to go ahead and copy it from PartyRock. Quickly, again, just review, make sure everything was copied correctly. See, I'm going to remove this triple tech YAML notation that allows styling in PartyRock, because we don't need that here, right? That's just for formatting purposes in our PartyRock app. And there's going to be 3 ticks probably at the bottom. Yeah, there is. We're going to remove that as well, so there's no errors associated with this OpenAPI schema. And we can see we have the schema for different methods implemented for subtraction, addition, and so on and so forth. And what's really important here is the description is also included for these paths. So this is going to tell agent which of these paths does it need to utilize. Okay, great. So we have everything here set up. I think we can go ahead and create this agent. So let's say create. Now that this agent is being created, this is also going to lead to the Lambda function being created for us as well, which is pretty convenient overall. So this has been created, and Lambda function has been created. So let's go ahead and find where that Lambda function is. I'm going to take a look at the list of Lambda functions I have, and I'm going to make this easy, let me just search for maybe calculator. Okay, so this is not the Lambda function name. Let's sort by last modified. So we can easily see it. 22 seconds ago, math operations. So that's the Lambda function that got created. All right, so with that, we scroll further down, and this is just a standard Lambda function. It doesn't have any logic necessarily, just set up for working with agents. So what do you need to do next? You need to go into the PartyRock and get the definition of your Lambda function. So let's go there, scroll further down to Lambda function, say copy to clipboard, and go back into Lambda and paste that in. Now, again, let's briefly just review this to make sure that we've copied everything correctly. Again, there's some notation here from generated by the LLM for styling and formatting purposes that I'm going to remove here. So I'm going to remove these 3 ticks Python and whatever precedes it. And let's go back to the bottom, see if there's any additional commentary. Yeah, we want to remove these 3 ticks and this additional commentary as well that has been created by the LLM to kind of explain, hey, what does this Lambda function do? So the rest of it looks good. If we just scroll quickly and review it, we have those API paths defined. We have the Lambda handler. Some of the helper functions are defined here as well. So I think this looks good. Why don't we go ahead and deploy? Click deploy here to deploy this code to Lambda. And at this point in time, we have everything set up. So the last thing we have to do is we gotta go and prepare the agent. So let's go to Agent Builder and let's save this configurations that we've set up for the agent. And now at this point in time, we can go ahead and ask Bedrock to prepare this agent, which is going to incorporate the latest changes and configurations we have in place and allow us to interact with the agent. Now, unfortunately, it looks like there's some errors, and I do have a script that is hiding some of these notifications. So let me go ahead and quickly disable this. I'm going to pull this off the screen for just a moment here so we can see what is causing issues with the preparation. And let me disable this JavaScript script that is blocking this. All right, so that's disabled. Let me bring it back to the screen here, and let's try and prepare the agent again. Now I'm going to just go ahead and try to do the same thing again. I'm going to save what we here have, and let's go ahead and prepare so we can see any error messages that pop up. All right, let's close this success message and says exception agent instructions cannot be null. Okay, so it looks like what we pasted for the instructions didn't quite go through. So let's go back to the PartyRock app and let's grab that again. So we're going to copy that. We're going to go ahead and paste that into the instructions. Let's just briefly take a look, making sure everything looks good. Yeah, everything looks good. Okay, so with that, let's go ahead and save again. We're going to just close this notification, save, and let's try and prepare the agent again. Let's see if we're able to get past this. All right, so it looks like failed to prepare. So there's an error during parsing of the API specific action. So it looks like this, based on what I'm seeing here, Math Operations Tool Model, Anthropic Claude 3.5 Sonnet, is going to require to add operation ID to our set of methods described in the Open API schema. So that's actually not an issue. We have that chatbot, that chat experience that allows us to interact with PartyRock to help us solve this. So let's see how we can do this. So I'm going to say here, just copy one of these messages and let's go to the chat experience of the app. And I'm going to say, hey, I am getting the following error when asking Bedrock to prepare the agent. And I'm going to paste that error below. I'm going to just include it in a nicely formatted way so that there's no misunderstanding around which part of this message is the error. Okay, so let's run this. And it's going to now say, I understand the issue. We need to add operation ID fields to each operation in the Open API schema to comply with Claude 3.5's requirements. So this is a requirement that Claude requires it to have. And now PartyRock is going through the process of regenerating the schema that is compliant, that includes operation ID here. So let's go ahead and copy that and go back to our agent builder. We're going to close this glaring red message, scroll further down, and we're going to go ahead and select here. Let's select this action group because that is where the Open API schema is that we need to update. Scroll further down to define via inline schema editor. We're going to replace what we previously had, paste the new definition. Again, just always validate what you're pasting to make sure there's no formatting or decorators available there. And it looks like it's good, right? It doesn't include any additional commentary by the LLM here. Let me just scroll further down and verify that that's true at the bottom. Okay, it looks good. So with that, what we're going to do here is we're going to go to the top and say, or actually to the bottom and say save. Okay, so with that being saved, let's go ahead and try to prepare the agent again. Now, with the agent preparation, we see that now it went through. See, the action group was updated, prepared the agent to keep its details up to date, and the preparation has been successful. So hopefully you can see how we can use this app that I've built in PartyRock, not to just build the artifacts, but also to try and troubleshoot some of the issues that you run into. So with that, we can now go ahead and start interacting with the agent, and I can ask it a question like, tell me what is 42 times 21? With 42, of course, being the ultimate answer to the universe. So let's run this and see what gets generated. So you can see that these traces are being emitted now, and it says your request rate is too high. Reduce the frequency of requests. Check your model before invocation quotas with the acceptable frequency. So this can occur when we are utilizing the model and have very limited capacity dedicated to our account, which is true for my current account here. Now, one way to potentially get around that is to change the LLM that is being used for reasoning. So let's go ahead and do that so we can see if we can get past this throughput issue that is being mentioned here. So we're going to go ahead and select, scroll further down, select edit, and we're using the Sonnet version 1. So let's try and select the Sonnet 3.5 version 2 right here. Let's give that a shot and see if we have sufficient capacity there. I'm going to say save here, and I'm going to choose once this is saved, we're going to need to prepare the agent again because now some of the configurations have changed. And I'm going to say test here, which is available right here, and say prepare. So as this agent is getting prepared, now the LLM that's being used behind the scenes is being swapped. And hopefully this also shows you how easy it is to swap the LLMs behind the scenes without having to rebuild or change a lot of the code in fact, you don't have to change any of the code for your agent. So I'm going to ask again, what is 42 times 21? And let's run this. Again, traces are being generated as the agent is thinking and going through the process here, and is going to come back and is going to say 42 times 21 is 882. But how do we know that the tool was actually used? We can take a look at the traces. So let's select show traces here. And I'm just going to zoom out a little bit so I can see a little bit easier here what is going on. And we're going to now open up the trace step 1, scroll further down, and you're going to find the text that was provided, which are our instructions for the arithmetic operation agent. Those are those steps that we've provided. There should be a total of 8 steps here. So let's take a look at the instructions generated here. And you can see, yes, there are 8 steps in total. Now, what is this aside from those 8 steps? Where it's talking about some of the other guidelines here. Think through the user's question, extract all data from the question and the previous conversations before creating a plan, and so on and so forth. As we can see, it's pretty detailed guideline. Hold on, we didn't specify that. PartyRock didn't generate that. That is an example of that pre-built, built-in prompt template that agent has, which you can customize and change if you like. But it's already designed to be built for best practices, so unless you need something very, very unique, you can, like me, just leave it and it will get appended to your instructions for the agent. We scroll further down here and we can take a look at the number of input and output tokens. Here, the pricing for Bedrock and by extension for agent is done based on the number of input and output tokens. So you also are going to have the similar pricing approach to what you typically do when you interact with the LLMs directly yourself. So we can see here the raw response being generated. And the rationale says I need to multiply 2 numbers, 42 and 21. I can use multiply numbers function for this calculation. So it's going to prepare the invocation input here. It's going to call the API path multiply within our Lambda function. And this is going to be a part of math operations tool. We're going to scroll further down to see the input 21 and 42 to Lambda function, and then take a look at the observation. So the observation from the tool from Lambda function is that 882 is the result. And then we can scroll further down to see the second trace. Let's just minimize the first one here. So trace step 2, we scroll further down. Again, we have the instructions system prompt for the agent, which includes our instructions as well as the part that was appended. We scroll further down and we can see the number of input and output tokens, the raw response, we can see the rationale, the multiplication has been performed successfully, the result is 882. So this is the agent rationalizing that the job has been done. So you can go back and return the result to the user. So the final response returned to the user is 42 times 21 equals 882, and that is in fact exactly what we got back. So what are you waiting for? Go ahead and explore this app in PartyRock. I'm going to include the link to it in the description of this video. And the best way to familiarize with some of these tools like agents is to go ahead and build them. You just saw a walkthrough how easy it is to build your own agent, and you can experiment with different capabilities for those agents. I've used a calculator as a tool, but you can specify something else. You can get a bit more creative. And again, if you're looking to understand a bit better how knowledge bases work and what they are, I'm going to include the link to the RAG walkthrough here in the video, so you can easily click there and go learn a little bit more about how RAG works as you start incorporating knowledge bases with your agents as well. So hopefully you enjoyed this video. Let me know if there's something specific that you'd like to see in the future videos, and I'll catch you next time.